Hey everybody, Mrmathblog here, and this lesson is rewriting percent expressions. Okay, so here's our Common Core strand, and then our question here is how can we rewrite expressions to help us solve markup and markdown problems? So like things that go on sale or people that, companies that mark up their prices and stuff. So a markup is one kind of a percent increase. Remember last lesson we did percent increases, and we'll do percent decreases also, so a markdown in just a bit. So we can use a bar model to represent the retail price of an item, that is the total price that includes the markup. So the retail is what the store sells it for, not what they purchase it for. So here's an example. So to make a profit, a store's mark, that should be a mark, golly, I think I make mistakes every time with you guys, mark up the prices on the items that they sell. Let's see, a sports store buys skateboards for a supplier for S dollars. What is the retail price for skateboards that the manager buys for $35 and $56 after they mark it up for 42% right there? Okay, so let's go ahead and answer this question here. So let's see. So let's go ahead and draw a bar model for the cost of the skateboard S. So what they purchase it for. So just draw any length of a bar. So there's that right there. Okay, and then so now draw a bar model that shows the markup price, okay, right below it. So 42% of S is a little bit less than 50%. So if 50% is right here, I'm going to draw a bar below it a little bit to the left of that. So something like right over there, and call that 42% of S, or 0.42 S right there. Okay, so something like that. Okay, all right. So now let's see. So now, oops, let me fix that up here. I just slid that up. Mark up. Dang it, Mrmathblog. Okay. All right. So anyway, so okay. So now what we're going to do is these bars together represent the cost of the markup plus the original cost right there. So right here, here's S, what the store bought it for, and then since they're adding on this much of a markup, then this is going to be their bar model representation of the total price that they're selling it for in the store. So here's S right here plus 0.42 S right there. Okay. All right. So these bars together represent the cost plus the markup, or S is 1S, so 1S plus 0.42S is going to get us 1.42S right there, where S is the store, what the store bought the boards for. So I think they bought them for, yeah, it says right here, it says they bought them for $35 and $56 right there. So now we can find out how much they're going to sell them for by plugging 35 in right there and 56 in right there, and that'll tell us what the store sells them for. Okay, so let's go ahead and do that. I'll just slide that up right there. So for the $35 board, we're going to do 1.42 times $35 gets us, it's going to be in sale in the store for $49.70. Nice little profit. And then for the $56 board, it's going to sell for $79.52. Oh boy. Note the 1.42, you guys. This 1 right here stands for 100% of the price plus the 42% of the price. So it's a nice shortcut, you guys. So 100% plus 42% stands for 1.42, 100% plus the 42% markup right there. Okay, so what if the markup is changed, instead of 42%, it's 34%? How does the expression for the retail price change? Well, remember, 100% plus 34% is going to get us 134%. So since the skateboards were S, then it would be 1.34S. Okay, all right, so Rick buys remote controls cars to resell. So he applies a markup of 10%. So write two expressions that represents the retail price of the cars. Okay, so the two expressions are going to be the 100% of C plus the 10% of C. Okay, so that's not one of them. So 100%, remember, of means multiply. 10% of C, so we're going to multiply 10. So we'll change this to 1.00 or just 1 times C, and this will be 0.1 times C. So here's one expression right there. Okay, and the other one is just combine those guys right there. That's what they're looking for right there. Okay, so write two expressions. Here's one of them, and then here's the other one right there. So if Rick buys a remote control car for $28, what's his selling price? So I'm going to plug in 28 right there for cars. C stands for the car's price right there. So 1.1 times 28, he's going to sell it for $30.80. Okay, that's about how much taxes are. I think it's about 10% or 11% here in California. Okay, anyway, so a clothing store triples the price of its item that it purchased resales. So what is the markup percent? And then write two expressions that represents the retail price of the clothes. Okay, I'm going to do part B first, you guys. It'll help explain what's the markup percent right there. Okay, so write two expressions. So it's going to be 100%. So what to make it, it's going to be 100% of the original, and we're going to tack on 200%. This is where we get 300%. This 3 represents 300%. So what's the markup price? The markup price is this 200% right there. Okay, so remember, it's 100% plus 200% will give us the 300%. So if it's going to triple in price, then it's going to go up by 200%. Because you got the 100% before. Hope that makes sense. Don't make this 300%, because that would make it go up to quadruple right there, because you got to consider the 100% plus this markup right here. Okay. All right. So an example of a percent decrease is a discount or a markdown. A price after a markdown may be called a sale price. So we can also use markdown models to represent this. So instead of adding, we're going to be subtracting right here. Okay. So here's an example. A discount store marks down all of its holiday merchandise by 20% off the regular selling price. So find the discount price of decorations that sell for $16 and $23. Okay, so let's draw bar models for this. So just draw any bar for P. So there's P right there. And then next we're going to draw a bar that shows 20% discount. So 20% is like 1/5, you guys. So if you think about driving these guys into 1/5. I don't know why when I start talking on this, my little dog Lucy wants attention, and she's here in my lap right here. So she doesn't have a squeaky, so you can't hear it squeaking all around anyway. So yeah, sorry you guys. So anyway, so 20%, think about 1/5, something like right there. So just draw a little bar down below right here that represents 0.2 of P right there. Okay, and then the difference right there, the subtraction of them, is going to be taking away the 20%. So if this is P and we take off this little chunk right here, then the rest of the P would be P minus 0.2P. Okay, so P minus 0.2P is the same as 1P minus 0.2P or 0.8P. So think of 20% off of 100% gets us 80%, which is 0.8. Okay, so now let's plug in the old prices of $16 and $23. Okay, so we plug those in and we get $12.80 they're going to be on sale for instead of $16, and $18.40 instead of $23. You get a 20% discount right there. All right, so a bicycle shop marks down each bike's selling price B by 24% for a holiday sale. So draw a bar model that represents this. Okay, so since it's being taken off, here's my bar model right here. So the whole bar, the whole entire bar is B. Okay, and then we're going to take off 24%, which is almost 25%, which is almost a fourth. So think of this being a half, so this would be a half right there, so a little bit to the left would be 0.24 instead of 0.25. Okay, so if we took this 0.24b off, then this part would represent the part that we're looking for, so 1 minus the 0.24b. Okay, so what is the single term expression for this? So what is 1b minus 0.24b? It's going to be 0.76b on that. Okay. All right. Okay, here's another one. So Jane sells pillows. For a sale, she marks them down 5%. So write two expressions. Now remember, 5% is not 0.5. That would be 50%. 5% is 0.05 because you got to move that decimal over 2 places. So assume it's right there if it's not given. So one place and then one more place, and so you'd have to add a 0. So 5% is 0.25. So write two expressions that represents the sales price. So one of them would be 1 minus oops, that should be a minus sign right there. 1 minus 0.2b. I don't know why I have an equal sign in there. Or 0.05p for pillows right there. And the other one is 1 minus 0.05 is 0.95 right there, okay? All right. If the original price of a pillow is $15, what's the sale price? Okay, so what I'm going to do is plug in 15 right here. So 0.95 times 15, that's going to get me $14.25 would be the sale price. Let me fix that. I send these lessons to teachers in my district. Okay. All right. So is a 20% markup equal to a 20% markdown? And explain. Well, no, it's not, because a 20% markup gives us a value of 120%. If you're marking it down, then we take it off of 100%, and that gets us an 80% value. So those aren't the same, you guys. All right, you guys. Hey, I thought this was kind of clever right here. So, all right, take care.